In this lesson, we are going to solve this question I have on the screen. The question says that the forces F1, F2, and F3, all of which act on point A of a bracket, are specified in three different ways. Determine the x and y scalar components of each of the three forces. So, for these three forces here, which are acting on this point A here, okay, all we have to do is to determine the x and y scalar components of each of these three forces here. So you have to find the x and y components of these three forces here, okay, in a scalar form. So let's look at how we are going to do this. So to do this, you are going to consider each of the forces. Okay, so you are going to consider the forces one by one. So first of all, I'll consider F1. Okay, so let's look at how we are going to do this. So if you have point A here, okay, and then we have F1 here being applied here. Okay, this is F1. Then that's equal to 600 Newton. Okay, so it makes an angle of 35 degrees with the horizontal. Okay, that's the x-axis. Okay, so all we have to do is to find the x and y component of this force F1. Okay, so let's look at how that is going to be. So the x and y component of this force will be this forces that I have drawn here. Okay, so this will be the y component. Okay, that will be F1y and then F1x. That will be the x component. So now I have the x and y component of this force. So all you have to do is to find their values. So let's look at how I'm going to do this. So to find the values of the x and y component, I'll first try and then take the cosine of the 35 degrees there. So cosine of the 35 degrees, okay, cosine will be the adjacent side over the hypotenuse, right? And then the adjacent side is F1x, okay, and then the hypotenuse is the 600 Newton. So I'm going to have F1x to be equal to 600 cosine of 35 degrees. Okay, so that's F1x. So let's do same for F2s. So for F2s, I'll take sine of the angle. Okay, so sine goes with opposite over hypotenuse. So the sine of the 35 degrees angle should be equal to the opposite side, which is F1y, divided by the hypotenuse, which is 600 Newton. So we are going to make F1y the subject. So we have F1y to be equal to 600 multiplying the sine of the 35 degrees angle. So we have this. So let's try and then simplify these values here. So F1x, which is 600 cosine of 35 degrees, that give me, okay, let me try this again. My calculator was set to radians, so I'll change it to degrees now. Okay, so it's in degrees. So we have 491.5 newtons. Okay, that will be the value of what F1x, which is the scalar x component of the force F1. So let's do the same for F1y. So that will be 600. That will be 600 sine of the 35 degrees. That gives us 344 newtons. So we have 344. Okay, let's make it 344.1. Okay, so that will be 344.1 newton. So this will be the x scalar component of F1, and then this will be the y scalar component of F1. So you can write this down. We are going to do same for F2 and F3. So I will go ahead and then free up some space so that we can do that. Okay, so now let's go ahead. So we're going to consider F2 now. Okay, so when you look at F2, you see that it doesn't really make any angle with the horizontal or the vertical axis. But I've been given some values here, which is the size of this small triangle that we have here. Okay, we know the 3 and then we know the 4. So you're going to use these values here, okay, to find the angle, okay, for F2. Okay, so let's draw F2. So okay, let me use white here. So let's say we have this horizontal line here, and then we have F2 here, and then this is our point A. Okay, so this is F2, then that's equal to 500 Newton. Okay, so you have that small triangle there. Let me draw this here. So one side is 3, one side is 4. Okay, and then this is the hypotenuse. To find the hypotenuse, okay, the hypotenuse will be equal to the square root of 3 squared plus, let me write this again, the square root of 3 squared plus 4 squared, right? 3 squared will give us 9, and then 4 squared will give us 16. Okay, so when we add this, we're going to have the square root of 25, which will be equal to 5. So that means that this side here is 5. Okay, so let's continue. Alright, so we now have all the sides of the triangle. So we can use this to find this angle here. You can use this to find this angle here. Okay, this theta here. Okay, so now let's look at how you're going to find that angle. Okay, so let's use this small triangle here. Okay, so for this small triangle, I'll redraw it here. Let me redraw the small triangle here. So you have this side to be 4, this side to be 3, and then this side to be 5. Then you have theta here. Okay, let's take cosine of this angle. Okay, cosine of this angle theta, okay, will be equal to the adjacent side over the hypotenuse, right? And the adjacent side is 4, and the hypotenuse is what? 5. So let's take sine of this angle will be equal to opposite over hypotenuse, that was 3 over 5. Okay, so we have those two sides there. So we know the cosine of the angle and then we know the sine of the angle. So I'm going to use this to find the component of the two forces. So now, okay, so I'm going to clean this triangle here. Okay, and then we use this cosine of theta and then sine of theta to find the component of this f2 here, which is f2x and then f2y. So let's look at that. So I'm going to have this to be f2x, and then f2y will be here. Okay, all right, so let's look at what is happening here. So let's take this angle to be theta f. Okay, let's name this theta f because I already have theta here. Okay, so okay, let's not make it theta f, let's use it theta. Okay, let's maintain the theta. Okay, so now let's continue. So let's take cosine of this angle here. Okay, cosine of theta equal to the adjacent side over the hypotenuse, right? And then we know the adjacent side to be f2x over hypotenuse, which is 500. So I'm going to have f2x to be equal to 500 cosine of theta. Okay, but now we know theta we know cosine of theta to be what? 4 over 5. So we can then substitute. So that will be what? 500 multiplying 4 over 5. So this was the reason why I made us not to use theta f here. Okay, and then we maintain the theta. So we are going to do the same for the y component also. So we are going to have sine of theta to be equal to, that's the opposite, right, over hypotenuse. That was f2y over 500. So we're going to have f2y to be equal to 500 sine of theta. But I know sine of theta to be 3 on 5, so that's going to be 500 multiplying 3 on 5. Okay, so I think I have to rewrite this again. Okay, so now let's simplify this to get the scalar component of this force here. Okay, so first of all, I'm going to compute 500 multiplying 4 on 5. So 500 times 4 on 5, that give me a value of what? 400. That give me 400 newtons. Okay, so now let's look at the direction of F2x here. Okay, so you see that F2x, okay, is pointing in the direction of the negative x axis. Let's look at what I mean by that. So if I have this to be the x and y plane here, okay, so this is the y axis, this is the x axis. So you see that at this part here, you have this to be the positive x and then this to be the positive y. Okay, and then you're going to have the negative y here. Okay, and then you're going to have the negative x here. So when you look at this arrow here, you see that it's the same arrow that you have for the x component of what? F2. Look at what I'll do here. Look at the direction of this arrow, and then look at the direction of this arrow here. So it's that they are all moving in the same direction, and then we consider this direction to be negative. So that means F2 here is going to be negative. So I will negate this value here. So we have F2 here to be what? Negative 400 Newton. But look at the F2y, it is moving upwards. Okay, which is the same as the direction of the positive y axis. So it will be positive. So let's simplify that. So that's what? 500 times 3 on 5. That gives me a value of 300 Newton. So that will be the y component for F2. So we now found the scalar component of F2 also. Okay, so now let's do same for F3. Okay, so let's look at how you are going to find the components for F3. Okay, so let's look at what I'm going to do here. So for F3, okay, let me try and sketch F3. Okay, so let's say this is point A here, okay, and then this is the negative y axis. Okay, we have F3 being applied somewhere here, right? So this is F3, and then that's equal to 800 Newton. Okay, so that's F3. So what you need to do is to calculate for this angle here, okay, which I name theta. Okay, you have to calculate for this angle here. So how are you going to calculate for this angle? Look at what I'll do here. So in the figure here, okay, let's look at what will happen there. So I'll draw this triangle here, okay. So I'll draw this triangle here. So you have this triangle here. Okay, so we have this triangle here. Okay, so from this triangle here, we know that from this end here, okay, to this end here is 0.4 meters. Okay, and then from this point here to the middle here is 0.2. So if I need this side here, that will be 0.4 minus what? 0.2, and then that will give me 0.2. So this distance here is what? 0.2. Okay, and then for the height, okay, which is this side here, okay, I can add 0.3 and then 0.1, right? That'll give me a value of 0.4. So now let's take this angle here to be theta. Okay, The angle is theta. So now you want to find theta. Okay, you want to find theta. So how do you find theta here? So let me draw the triangle. So you have this triangle here. You have this side to be 0.2. Then you have this side, that's 0.2 meters. And then this side to be 0.4 meters. And then you know this angle to be theta. So you want to find this angle here. To find this angle, I can take tan of the theta there. So that will be what? Tan theta. That will be what? Opposite over adjacent, right? So that will be what? 0.2 divided by 0.4. Okay, so 0.2 by 0.4, that give me 0.5. So theta will equal to tan inverse of 0.5. So let's see the value of that. So that gives me an angle of 26.6 degrees. So that will be the angle that is here. Okay, so I can claim this theta here. Okay, and then redraw this force here so that I can indicate it here. So this is F3, and then that's equal to 800 Newton. Okay, and then we know this angle now to be 26.6 degrees. So now let's find the x and y component of what? F3. So this is going to be the x component, which will be F3x, and then this will be the y component, okay, which will be F3y. Okay, so now what do we do next? All we have to do is to find the value of the x and y components. Okay, so let's go ahead and then look at that. Okay, so I will find a way to find the values of the x and the y component of this f3 here. So first of all, let's take cosine of this angle here. Okay, cosine of 26.6 degrees, that will be equal to the adjacent side of our hypotenuse, right? So that will be f3y over 800. Okay, so we are going to have f3y. Okay, we're going to have f3y to be equal to 800 multiplying cosine of the angle 26.6 degrees. Okay, so let's simplify this and see what you get. That will be 800 multiplying cosine of 26.6 degrees. So that gives me a value of 715.3. Okay, so I have 715.3 here. Okay, that's 715.3 Newton. But look at the direction of the F3, right? It is pointing downwards, which is in the direction of the negative y axis. So you will have to negate it. So that will be negative 715.3 Newton. So let's do the same for the x component, which will be what? F3x. So let's take sine of the 26.6 degrees. That will be equal to opposite, which will be F3x over hypotenuse, that was 800 Newton. So I'm going to have F3x to be equal to 800 sine of 26.6 degrees. So let's see what we get for that. I'm going to have 800 sine of 26.6 degrees, right? So that gives us a value of 358.2 Newton. So I'm going to have 358.2 Newton. Okay, and then of course you see that this is actually moving in the positive x-axis direction, so it will be positive. So that will be the value of the x and y component for the third force also. But for the third force, okay, we can use another method here, okay, where we will multiply the magnitude of the force by the unit vector, okay, of the force there. Okay, so I'm going to find the position vector of this force F3 here. Then after finding the position vector, we find the unit vector of that position vector, then we multiply by the magnitude of the force. If you have an idea about unit vectors, you can try your hands on it. Then after that, you compare your answer to what we had. So we had 715.3 and then 358.2. Okay, that's for the component of F3. Okay, so I won't clean that. I will leave them there. Okay, so let me write this here. So for F3Y, okay, that was equal to minus 715.3 Newton. Okay, let's do for F3X. That would be 358.2 Newton. Okay, so let's use the other method and see what will happen. Okay, let me free up some space so that we continue. Okay, so now to use this method, you will need the position vector and then its unit vector. Okay, so let's look at how we're going to find the position vector. So the position vector is a vector that is traced from the origin. Okay, so let's look at how that is going to be. So assume you want to locate this point B here. Okay, assume you want to locate this point B here. I can move from the origin. Okay, I can move a certain distance from the origin, that's on the y-axis. Okay, then I'll move a certain distance on the x-axis to locate this point B here. Okay, let me bring this here. Okay, I can move a certain distance to locate point B here. So you see that I move a certain distance on the y-axis and a certain distance on the x-axis. So that's what will give us the position vector. Okay, so when I want to locate this point B3 here, sorry, this point B here, okay, I can move a distance of 0.4. Okay, I can start from here and then move a distance of 0.2 in the x-axis direction and then move a distance of what, 0.4 in the y-axis direction just to locate this point B here. Okay, so that's what this means here. So you're going to have the vector here. Okay, let's name this V. Okay, that's going to be 0.2i. Okay, because you're going to move a distance of 0.2 in the x direction, then you move a distance of what, 0.4 in the y direction. But for the y direction, you see that it is pointing downwards. Okay, which means that you are moving in the direction of the negative x-axis. So that's what, minus 0.4j. Okay, the I and j are unit vectors. Okay, which will just telling us that for this part you are moving on the x-axis and then for this part you are moving on the y-axis. So to find a unit vector of this position vector, then you need the magnitude of this position vector. So let's find the magnitude of this position vector. So that will be equal to the square root of 0.2 squared plus minus 0.4 squared. Okay, so let's simplify this and see what you get. So the square root of 0.2 squared plus minus 0.4 squared will give me a value of root 5 on 5. Okay, root 5 on 5. So let's write this here. Root 5 on 5. Okay, so for this to be a little bit simple, I'm going to write this in decimals. Okay, so I write this as 0.45. Okay, 0.45. Okay, so now to find the unit vector of this position vector, okay, which I name as u, that will be equal to the vector divided by its magnitude. So we know the vector to be 0.2 That's 0.2i minus 0.4j, right? This divided by the magnitude of the force. Okay, sorry, magnitude of the vector, which is 0.45. So we're going to have 0.2 divided by 0.45. That's a mistake. 0.45i, okay, minus 0.4 divided by 0.45j. Okay, so let's simplify this and then see what you are going to get. Let me continue writing from here. So we have the unit vector to be 0.2 divided by 0.45. That give me 4 over 9i, okay, minus 0.4 divided by 0.45, and then minus 8 over 9j. So now, to find the component of this force here, okay, to find the component of what force F3, all we have to do is to multiply the magnitude of the force, which is the 800, by the unit vector. So let's go ahead and then look at that. Okay, so you know the unit vector, so let's multiply it by the magnitude of the force, which is the 800 Newton. So I'm going to have F3 multiplying U, right? That's going to be 800 multiplying 4 on 9i minus 8 on 9j. So let's simplify this. So 800 times 4 on 9. Okay, that actually gave me a value of 355.5, and then minus, okay, 355i minus 800 multiplying 8 on 9. Okay, that gave me a value of 711.1. So I think this is because of the rounding of the numbers. Okay, so what I'll do is that previously, um, we got the magnitude of the force to be root 5 on 5. Okay, if you remember. So this is what you got, right? So I'm going to use this to find the unit vector once again. So let me clean this. I want us to get a value close to the answers we got previously. Okay, so I'll clean all these values here, then we'll try this again. So let's find a unit vector. So that will be equal to, you have 0.2 divided by root of 5 on 5i, okay, minus 0.4 divided by root of 5 on 5j. Okay, so now in this case, you're not using decimals anymore. So let's simplify and see. So in simplifying this, okay, I'm going to have u to be equal to 0.2 divided by square root of 5 on 5. Okay, 0.2 divided by square root of 5 on 5 still give me square root of 5 on 5. That is square root of 5 on 5 I. Okay, minus, let's multiply, so let's divide 0.4 by square root of 5 on 5. That also gives me minus 2 root 5 on 5j. Right, so now let's multiply this by the 800 Newton. So I'm going to have 800 multiplying the u, 800 multiplying the u. So that's going to be 800 times square root of 5 over 5i, okay, minus 800 times the square root of, that's 2 root 5 on 5j. So let's simplify this. So I'm going to have 800 times square root of 5 on 5. Okay, so that gave me a value of 357.7, okay, which is actually close to this value that we got here. Okay, we can round this to 358 newtons, okay, which is close to the value we got here. So now let's do same for the second term. So that what 800 times 2 root 5 divided by 5. So that gives us minus 715.5. Okay, 715.5 J. So you see this is also close to the value that you got at first. So if you don't want to use the method we use first to find the component of F3, then you can use this method also. But you have to be careful of how you round the numbers, okay, because when I used the 0.45, the answers were very far from what we got. Thank you very much for watching this video. Please make sure you like and subscribe.